As we begin studying calculus, you'll find that calculus is the study of limits. In order to study limits, we have to have an idea of what a limit is and how to find the limit. At the end of this lesson, you'll be able to find a limit both numerically and graphically. All right, let's first of all figure out what is a limit. Here is the great informal definition. If f of x becomes arbitrarily close to a single number L as x approaches c from either side, the limit of f of x as x approaches c is L. Just in case you didn't quite get that informal definition, let's go really informal. Okay, let's say we've got a function. I'm just going to make a function. Let's just do x squared. How about? Now, if f of x becomes arbitrarily close to a single number L, we know that f of x really is just a y value. So it's just saying if our y value comes really close to a certain number, and we're just going to call it alpha right now, as x approaches c from either side. So we need an x value of c. I'm just going to put it right here for right now. It doesn't really matter where we put it. If what's happening, if as I come in, if I'm tracing the graph from one side and I'm tracing the graph from the other side, if I'm reaching the same y value from both sides, that y value would be known as our limit, and we actually call it L. We actually will call it 5 or 2 or -1 or whatever it is. We won't actually give it the name L. All right. To find a limit, one way that we'll do it is numerically. And if I ask you to find the limit numerically, I would like you to construct a table of values with x values approaching c from the right and from the left. If I ask you to find a limit graphically, you'll need to sketch a graph and trace with your finger or your calculator as x approaches c from the right and left. And now we're going to do 3 examples just to give you a good idea of what this involves. All right, the first example says find each limit both numerically and graphically. The first one you'll notice is asking us to find the limit as x approaches 2 of the function x minus 2 over x squared minus 4. You'll notice I already have the table set up for you. Notice we're approaching 2, so you'll notice 2 is actually right here on my table. Notice I have values getting closer to 2 from the left, and I have values approaching 2 from the right. So what we're going to be looking for now is we're going to be looking at the y values as I get closer to 2 from the left side, and I'll be looking at the y values as I get closer to 2 from the right side and see if they match up, and if they do, that will be our limit. All right, so we are going to actually use our calculator to find that. Before we get going on our calculator, there's a couple things that we have to do. The first thing, you were probably using statistics on your calculator the last time you used it, so we need to turn that stat plot off so we don't get a bunch of dots on our screen. So we're going to go to stat plot, which is second y equals. Notice my stat plot is on. I want it off, so just press enter, and let's arrow over and turn it off. So please be doing that with your calculator also. The second thing that we want to do is we want to put it back to the standard screen. So go to zoom 6, and that will just get us back to the normal screen that we're used to viewing. As I'm going through these examples, I would definitely suggest having your calculator out too and working through the examples right with me, because I think it will be easier for you to catch on if you're actually physically involved in punching stuff in your calculator also. Let's go ahead and type in the equation. So I'm going to have in parentheses x minus 2 divided by, and I'm going to put, try that again, 2 parentheses divided by x squared minus 4, and I do have to put that in parentheses as well. If you've got a new operating system, yours might be a little bit easier to enter. Okay, whoops, now I have too many parentheses. Let's go up here. And I'm just going to get rid of one of those. Okay, we should be set. Now I'm going to go to table, which is second graph. And you'll notice I already have the x values entered in. All you just have to do is type them in and press enter. So I'll give you a minute to type those in. And then I'm going to go back to my problem. And I'm going to go ahead and enter those values for when it was 1.9. It was 0.25641. When it was 1.99, the y value is 0.25063. When the x value is 1.999, we've got 0.25006. For 2.001, we've got 0.24994. For the next one, we have 0.24938. And then for that last one, we have 0.2439. So if you're looking at the y values, as I'm approaching from this way, please notice that my y values are getting closer and closer to 0.25. As I'm coming in from the right, you'll also notice that my y values are getting closer to 0.25. So since we're approaching a single number from both sides, we can say that our limit is equal to 0.25. We could also say that the limit equals 1/4 if we wanted to. Okay, now let's approach this graphically. Again, we're going to use our computer to help. Okay, this time we'll just go ahead and press graph. And if I press graph, you'll notice what I'm getting. We would like to approach 2 from both sides. So probably the easiest way to do that, if I just have a graph on my screen right now, we are going to press trace. And I'm just going to press the right arrow and I'm going to try to get close to 2. So just watch the x's getting closer to 2. And as I'm getting close to 2, whoops, notice on the right side of 2 it's 0.24. On the left side it's 0.25. So you'll notice again I'm getting pretty close to 0.25. You'll find that the graph, especially on this problem, is not a real good way to do it because it's hard to get exactly as you could from the table. So if I just draw that on my notes, there was an asymptote happening at x equals -2. So I'm going to go ahead and draw that. Whoops, that was a bad asymptote, sorry. Okay, so my problem, something like this. And then just again, notice when x approached 2, as I was coming in from the left and as I was coming in from the right, I was approaching that same y value of 0.25. So that would be the limit for that problem. All right, let's try the next one. Again, we're going to do it numerically. Notice that I'm approaching -3. If I looked at my chart, you'll notice -3 is right in the middle, and then I just got a little bit bigger on each side as I went out. Okay, and we'll practice that in the next problem, actually picking our numbers. Okay, so again, we're going to be looking at the y values as I come in from -3 from the right and in from the left. So let's go back to our calculator. Okay, this time we're going to go back to y equals. Let's clear the one that was in there. We would like the square root of 1 minus x minus 2 on the top. We have to use a little bit more parentheses this time. I need a square root for, I need a parenthesis for the whole numerator. And then I also need, I'm going to go ahead and press square root. Notice I'd get an extra set of parentheses for the square root. So 1 minus x, close the square root parentheses, and then minus 2. Now we're closing the numerator parentheses. And now divided by, put the denominator in parentheses, we're going to have x plus 3. Sometimes the trickiest part is just trying to get these entered. Okay, I have it entered. I would like a table again. So second graph. Notice this time I don't have the right numbers in there that I want, so I'm going to type them in. -3.1, -3.01, -3.001, and then we're on to -2.99999, -2.99, and -2.9. Okay, so now if you'll go ahead and take a look at those y values, I'm going to go ahead to my other screen and record that information. Okay, this first one was -0.2485, next one -0.2498, next one -0.25, next one -0.25, next one -0.2502, and next one -0.2516. So you notice the y values as I'm coming in from the right, these y values are getting closer to -0.25, and as I'm coming in from the left, those values are getting closer to -0.25. So I can say that my limit is equal to -0.25 or -1/4. All right, if we take a look at it graphically, let's go back to our calculator. All right, let's go ahead and press graph. And if I press graph, you'll notice I really get this kind of straight looking line, and I really don't like it what it looks like. So I would like to get a better picture of what it looks like. So I'm going to zoom in, zoom to, and I'll just press enter. Please notice that when I do that, I get something that looks a little bit better. And if I'm approaching -3, let's just again hit trace. And let's get over to -3. This might take a little while because I'm just too zoomed in. Let's see if it will keep bringing me past my screen. Yep, it does. Oh, there we go. And notice I'm getting close to negative 0.25. So again, graphically, kind of a little bit harder to find because that whole tracing bit is kind of a pain. So definitely better to do a table on this one, but we can still do it graphically. All right, let me go back to my screen. So graphically, I'm just going to draw a picture of what that looked like. It looked something like that. But again, as we were approaching negative 3, when I was going in from the left, and as I'm coming in from the right, I am approaching that 1y value, and that 1y value again was negative 0.25. All right, let's do one more example. This time I have the limit as x approaches 0 of cosine x minus 1 divided by x. You'll notice on this one I did not give you x values, so I'm going to go ahead in the middle of those. I'm going to go ahead and put our limit, which is 0. So I need to just get further away from 0 from both sides. The first one I'm going to do is negative 0.001. And on this, then we'll go negative 0.01 and then negative 0.1. Okay, on this side, I'll do positive 0.001, positive 0.01, and positive 0.1. So now let's go ahead to our calculator and find those on our table. Okay, in the y equals screen, let's clear out what's there. And I'm going to get rid of all that key history. There we go. All right, in the numerator, we have in parentheses cosine x minus 1. Notice when I press the cosine, a parenthesis automatically shows up. So we'll just do x and then close that back up. And then minus 1. We're finishing the numerator, so let's get that numerator parenthesis in there. And then divided by x. So we can just type in x. And then again, we're just going to go to the table. And then we'll just type in the values that we picked. We picked negative 0.1, negative 0.01, negative 0.001, and then we'll go in the positive direction here, 0.001, 0.01, and 0.1. All right, so we've got it in our table. So now, one thing that I would like you to notice before I go back to my other screen, if I have 5e to the negative 4, that means move your decimal 4 places to the left. So that really means 0.0005. And the next one means negative 0.0005. So just keep that in mind as we write those values down. Okay, so on my chart, I have negative 0.04996. And then I have 0.005, and then I have negative 0.0005, and then I have, whoops, that's a positive, isn't it? Sorry about that. That's a positive one. I think this might have been positive also. Okay, this was negative 0.0005. This one is negative 0.005, and this one is negative 0.05. So as I'm approaching from the right, I notice that actually this number is getting closer and closer and closer to 0. It's getting smaller and smaller and smaller. And then on this side, even though it's a positive number instead of a negative number, this number is also getting smaller and smaller and smaller, and it's getting closer to 0. So the y values from either side are getting close to 0, so we can say that our limit is equal to 0. And then let's just check that out graphically. So let's go to our calculator. All right, we've got y equals, and now I can just go ahead and press graph. And I probably could have zoomed back out, but we're close to 0, so that's fine. So please notice is if I go ahead and trace it, as I get close to 0, notice that number is getting pretty close to 0. It's not defined at 0, but we don't care. And then again, even though it's turning negative, it was still a value close to 0. And again, graphically, it was really hard to tell that it was 0 because it doesn't zoom in quite enough for us. So if we draw a picture of that on our notes, we should have a picture that looks something, whoops, like this. And so as I'm approaching from this side, and as I'm approaching from this side, I am approaching that same y value of 0. So again, my limit would be 0. So now you should be able to find the limits of a function both numerically and graphically.